Tables question number 2 is from the 2013 exam. It was a non-calculator question. And in this question, I'm given a table of values for C, which is the amount of coffee in a cup. In part A, I'm asked to approximate C prime of 3.5. This is that question about using the average rate of change to approximate the instantaneous rate of change. So I need to find where 3.5 lies in my table, and it's right here in between the 3 and the 4. So I'm going to use this portion of my table, and you see that difference quotient is shown right here. So you must show the 12.8 minus 11.2 over 4 minus 3. That earns you this first point. You don't have to simplify it any further. I'm also asked to indicate units of measure. The 12.8 and the 11.2, their units are ounces. That means in my numerator, I'm going to write ounces. And the 3 and the 4 have a unit of minutes. So in my denominator, where the 4 and the 3 are, I'm going to write per minute. That unit will earn you the second point. The only time you have to indicate units of measure is if you're told in the problem that you have to indicate units of measure. Otherwise, you can just not do that. In part B, I'm asked if there's a time on the interval from 2 to 4 where C prime of t equals 2. Because my table has C values and I'm asked about C prime, that's a clue that I'm going to use the MVT on this one. In order to use the MVT, I need a differentiable and continuous function. What I'm told in the stem of the problem is I have a differentiable function. But we know if a function is differentiable, it is automatically continuous, and therefore I can use the MVT. Now what I need to do is find an interval where the average rate of change is 2. And I'm just going to use this interval from 2 to 4. I'm going to show my difference quotient as I did right here. And I get my answer of 2. And since the average rate of change on that interval is 2, there's a place where the instantaneous rate of change is 2. Point-wise, if you just show an average rate of change equaling that point in question, you're going to earn this point. And if you have all the other parts of the problem about laying out that hypothesis and drawing a conclusion, which I have in steps 1 and 3, you're going to earn that second point. Part C wants me to use a midpoint sum with 3 subintervals of equal length to approximate 1/6 of the integral 0 to 6 c of t dt. The midpoint Riemann sum is going to be used just to approximate this part. So make sure that you have the 1/6 just hanging on the outside, and then I'm doing my midpoint Riemann sum. To do this midpoint Riemann sum, I'm going to split this into 3 equal subintervals, so from 0 to 2, 2 to 4, 4 to 6, and within each of these subintervals, I'm going to pull the middle value. So it's going to be 2 times 5.3. The next one is going to be from 2 to 4 is 2, and the point in the middle is the 11.2. And then my last one is from 4 to 6 is 2 units wide, and my middle height is that 13.8. The midpoint Riemann sum right here is worth this point, and getting it down to that answer of 10.1 is the answer point of 1. Without a calculator, my advice would be don't do any of this. Just stop it with that original statement. And if you do that, you're going to earn 2 points with that one statement. I'm also asked to explain the meaning of that integral. Any integral explanation needs 3 parts. You need to say what it is, units, and what the limits mean in the context of the problem. For this particular one, the fact that I see a 1/6 hanging out in front is a red flag that this is an average value. And it's the average value of whatever is sitting as my integrand, which is C, which is defined to be the amount of coffee in the cup. So I have the average amount of coffee in the cup. That's the what. I have my interval, 0 minutes to 6 minutes. And then I have my units, which is given in ounces. I incorporated my actual answer of 10.1, but you don't have to do that. You could just say the average amount of coffee in the cup in ounces from t equals 0 minutes to t equals 6 minutes. And then in part D, I'm given a function b, which is the amount of coffee in the cup, and I'm asked to find the rate at which this amount is changing. We know that a rate simply just means a derivative, so I just need to find what b prime is. The constant of 16 is just going to zero out, so the 16 is gone. And then I need to do the derivative of negative 16e to the negative 0.4t. That's an exponential derivative, and that rule is you write down exactly what you see times the derivative of the exponent. And the derivative of that exponent is the negative 0.4. You can simplify this if you want to, but without a calculator, I would just leave it exactly as I have boxed and earn your point. I'm asked what this rate is at t equals 5, so I just replace the t with a 5. And again, you don't have to do any of these calculations. I would totally advise just leaving it as I have boxed right here, and then you would earn that 9th point.